All right, this video is part 2 of a series on parallel, perpendicular, and oblique lines. In part 1, we started doing some examples. We did AB, and we did example number C here. And then we asked you to have a go at examples D, E, F, and G. We hope that you have done that. If you have, then this session is going to be much more useful to you than if you haven't. All right, so let's go on to D then. So in D, we have L1 is 2x plus 3y is equal to excuse me, 11. L2 is the 7x minus 2y equal to 1. We're going to write these two equations in standard form so that we can extract the gradient m and the y-intercept c. L1 is going to work out to 11 over 3 minus 2/3 x. So from here, m1 is minus 2/3. So that tells us that the line L1 is downsloping. Then C1 is 11 over 3. Then go to L2. In L2, y is going to be 7 over 2x minus 1 over 2. So that tells us that M2 is 7/2. So the line is upsloping this time because m is positive. And then C2, the y-intercept, is going to be minus 1/2. Looking at the two gradients, we can see that they are not equal. So that means the lines are definitely not parallel, but we need to test whether the lines are perpendicular. So work out the product m1 times m2. So this gives us minus 7 over 3. This is not equal to -1. So this tells us that L1 and L2 are oblique. All right. So there's going to be a point of intersection, and there's going to be an angle of intersection which is different from 90 degrees. Okay, this time we're going to first work out the angle of intersection. So if we make a sketch of L1, so L1 goes through E0, 11 over 3. So just put it there, and the gradient is -2/3. So it means this line is going to go something like this. So m is -2 over 3. That is 11 over 2. So that's L1, and then L2 goes through 0, -1/2. So somewhere this side, it's got a gradient of 7 over 2. So it's very much upsloping. So this one, M2 gradient is 7/2. So for the angle of inclination, we are looking for this angle here. So what I want to do is we're going to make use of this triangle here. Okay, so let's start with the inclination angle for M2. So let's call that one theta 2. So theta 2 is going to be inverse tangent 7/2. So inverse tangent 7/2 works out to 7/2 is equal to 74. So maybe let's write it down, 74.05. So that's going to be that angle there. And then for the first line, inverse tangent -2/3. Okay, this one is going to be, so inverse tangent -2/3 is -33. So remember we said 33.69. So we said the reason why it's negative is because it's on the left of this line. But if you just use the positive value, so that one is going to be positive. So since we are interested in just the size of the angle, then this angle here is just going to be given by inverse tangent 2/3. Okay, it's the negative simply tells us that it's on the left. If you remove the negative, you just get the size of the angle. So that means our intersection angle theta is going to be 180. Take away the inclination angle of L2 plus inverse tangent 2/3, which is the positive of the inverse tangent of the gradient of L1. Okay, because this angle here plus this angle here plus theta must be 180, and then we simply punch this in the calculator. So when we do that, so 180 minus open brackets, so we're going to have inverse tangent 7/2 plus inverse tangent 2/3 2/3, and the angle is 72.26. So 72.26 is our angle there. All right, so that is the inclination angle. We still have to find the point of intersection. We're going to use substitution this time. So notice we have, or maybe we'll just use elimination. So our two equations are 2x plus 3y equals to 11, 7x minus 2y equals to 1. What I want to do is we're going to multiply this one by 2 and multiply this one by 3. So we're going to have 4x 6 plus 6y equal to 22. And here we're going to have 21x minus 6y is equal to 3. And then when we add this, we're going to have 25x. The y terms will cancel out. We're going to have 25 that side. So that tells us that x is going to be equal to y. Then if we plug in x is y 1 in this equation, for instance, we're going to have 7 over 2 times 1 minus 1/2, 6 over 2, so y equals to 3. So 1, 3 is the point of intersection. All right, so that sorts out that example number D. We're now going to go to E. In example number E, the two equations we have 2x plus y equal to negative 8, x minus 2y equal to 7. Just go up here to confirm. Yes, E. So 2x plus y is negative 8, x minus 2y is 7. So let's call those ones L1 and L2. If we make L1, make y the subject of L1, going to have minus 8 minus 2x. Make y the subject here, going to have x over 2 minus 7 over 2. So this tells us that M1 is negative 2, C1 is negative 8, M2 is 1/2, and C2 is negative 7 over 2. So again, just a simple comparison of the two gradients. This is one gradient, this is the other. They are not equal, so the two lines are definitely not parallel. So, but then we need to compare, work out this product here. This product works out to -1. All right, so since M1, M2 is equal to -1, the implication is that L1 and L2 are perpendicular. If they are perpendicular, it means we already have the angle of intersection. 90 degrees is the angle of intersection. So all that remains now is to find the point of intersection. So let's see how we can find that point of intersection. So here we've got y equal to negative 8 minus 2x. So we are going to take this thing here and we're going to plug it into the equation of L2. Okay, So substituting into L2, we're going to have x minus 2 into minus 8 minus 2x, and this is equal to 7. So we're going to have x plus 16 plus 4x is equal to 7. X plus 4x is 5x, 7 minus 16 is negative 9. So this is telling us that x is equal to negative 9 over 5. Whenever we've got non-exact answers, we prefer to leave them as fractions rather than decimals. So from here, y is going to be negative 8 minus 2 times negative 9 over 5. This is going to work out to negative 22 over 5. So the point of intersection is minus 9 over 5 minus 22 over 5. Now, mind you, these can always be checked by plugging them into these equations. So for instance, if you plug them here, they must give you negative 8. Then when that happens, you know that it's good. Actually, maybe let's just do one of those. So we've got 2x plus y is negative 8. X is negative 9 over 5. So we can do that in the calculator. 2 times negative 9 over 5. So negative here, it's 2x plus y. So this is going to be plus, y is negative 22 over 5. So this must give us negative 8, and indeed it does give us negative 8. So straight away then we know that that is correct. So this is the point of intersection. All right, so that is E. We're now going to go to F. In F, we have got 2x plus 5y is equal to negative 3. 0.4x plus y is equal to 5. Call this L1, call this L2. If you make y the subject of the formula here, it's going to be minus 3 over 5 minus 2 over 5x. Make y the subject of the formula here, it's going to be negative 0.4x plus 5. But negative 0.4 as a fraction is negative 2 over 5. So this is telling us that m1 is negative 2 over 5, and it is equal to m2. This is implying that L1 is parallel to L2. So there is not going to be any point of intersection. So that's the end of F. Now let's go to G. G, we've got 4x minus 3 is minus 11, and 3 is supposed to be 3y, but it's coming from the part 1 where it was correctly written. So G 4x, so use different color. 4x minus 3 is negative 11. 3y plus 12 equals to 0. This is L1, this is L2. We said whenever there's only one variable, we make that variable the subject of the formula. So in this case, we have got 4x is equal to negative 8. So x is negative 2. Here we've got 3y is negative 12. So y is negative 4. So I've got these two straight lines now. If you are going to, if you have looked at our video on the equation of the straight line, part 1, then we will you will be aware that x lines are vertical lines. So x equals to 2, negative 2 is going to be a vertical line somewhere there. Y lines are horizontal lines. Y equals negative 4 is going to be somewhere there. So straight away we see that L1 and L2 are perpendicular, and so the intersection angle is 90. Intersection angle. The intersection point is just this one. Negative 2, negative 4 is the intersection point. Okay, so this example just demonstrates that you shouldn't go through everything like a robot. Just work through the equations given and remember everything, and then things will sort of show themselves to you. All right, so this is the end of this video. Thank you very much for watching this. Hopefully it has been useful. Please do subscribe to our channel so that you can get notified whenever we post new material.